Hi, today we will be looking at a question from relative motion. So first let us go through the question. I have it here. Eklavya, okay, who is 12 meters away from a mango tree, takes aim directly at a fruit hanging at a height of 5 meters. Okay, just as he shoots his arrow, the fruit drops down. Okay, this is important. Drops down. Arrow strikes the fruit after 0.8 seconds. The question is to find the initial speed of the arrow. So basically, the situation we have is I'll sketch it here. I'll create the rough diagram. So there's a tree here, right? There's a tree here. We'll give it another color. Yes. And there's a person standing here with a bow shooting fruit. Let's think it's a raw mango fruit, which is at a height of 5 meters from the ground initially. Now, the person takes aim at the fruit. Let's say he either expected the arrow to fall down or his aim went wrong. The fruit fell down right or drops down right at the instant he shoots the arrow. So, the fruit is here after 0.8 seconds, and it is given that the arrow strikes the fruit after 0.8 seconds. Okay, now we are asked to find the initial speed of the arrow. So this is 0.8 seconds to reach here, and I'm sure you are able to calculate the height at which the fruit will be at zero point 0.8 seconds, but that is not necessary in this problem. This is a problem based on relative motion, but mainly we will be using coordinate geometry to solve the problem. Now, this distance is given to be 12 meters. What we'll do is we'll write the time dependent coordinates of both the fruit and the arrow. So it will be in terms of t and some constants. And after writing this, what we will do is at 0.8 seconds, the arrow strikes the fruit, which implies that the coordinate of the arrow as well as the fruit at 0.8 seconds must be the same. So, equating both coordinates, we will be able to calculate the velocity of the arrow, initial velocity of the arrow. And any other thing required can be calculated once we get that information. So, let's assume the initial velocity of the arrow to be v, and we can resolve it into two components, v horizontal vh comma v vertical vv. Okay, now we'll be writing the equation or writing the coordinates of both with respect to time. So let's say at time equal to t, fruit, first we will write it for the fruit. Now we know that the x coordinate, which is 12 meters, is independent of time because the fruit is dropping vertically. So when it drops vertically, there is no horizontal motion, and hence the horizontal component or x component of the position will be constant, which is 12. Right. With that, then we'll consider the vertical component. Vertical, it's going to be interesting. So before that, we need a small assumption, like we need to define the direction which we are taking as positive. I'll be taking upward direction to be positive. Your choice, definitely, by the way. I'll take upward to be positive. And since it is being dropped, initial velocity will be 0. So, before filling in the y coordinate, I'd like to revise on one thing. Galileo's second equation of motion S is equal to ut plus half at square. Okay, this is a relation connecting displacement, initial velocity, time and acceleration. Here acceleration is equal to minus 10 meter per second square. We are considering g to be 10 meter per second square, hence minus 10 meter per second square. Initial velocity is 0, so this term goes to 0. So this will be minus 5t square, and displacement is final position minus initial position. If we consider the final position to be y minus 5, because initially it is at a position of 5 upwards positive, but y is negative downwards. So with respect to y, it will be y minus 5. Okay, this is S. So we will be able to write y is equal to 5 plus half at square, but a is minus 10, so 5 minus 5t square. Okay, so this will be 5 minus 5t square. Okay, both are in meters, so I am not writing the unit. I hope this is clear. Now we will consider for the arrow at time t. Once again, I will write it. For the arrow, it is a bit more interesting. In case of the arrow, the horizontal velocity Vh, it is not affected by g, the acceleration. Why? In projectile motion, we understand that the horizontal velocity and the vertical velocity are independent of each other. So, since the acceleration is acting in the downward direction, only the vertical component of the velocity will be affected. The horizontal component remains the same. So, initially, if it was Vh, it will remain Vh into time t. That will give you the position Vh into t. So, Vh t is the position, comma, vertical component again will be affected by acceleration. So, once again we will have to write an equation like this here. I'll write this one in red here. S is equal to ut plus half at square. Now, u initially is Vv, that is V vertical into t minus 5t square. Again 5t square because minus 10 meter per second square acceleration downwards, that is 10 meter per second square acceleration downwards, so minus 10 meter per second square will be the sign convention. So vvt minus 5t square. Again this is obvious, velocity will be decreasing. Okay, so this will be s. Substituting this here, we get v vertical into t minus 5t square. Now at t equal to 0.8 seconds, as I conveyed during the beginning of the video, when the arrow strikes the fruit, the position of the arrow and the position of the fruit is the same. Hence, the coordinates must be the same, and by equating the coordinates, we get the value of VH and VV. Now, doing the calculation, VH into time t equal to 12, t is 0.8, of course, so VH equal to 12 divided by 0.8, which is 120 by 8, 50. Now, just a minute, I will just shrink one part. This is an optional part just to show the calculation, so I think I can shrink this. This way. Let me shrink this. Yes. And I think I'll mark this. Like this calculation is for this part, and this calculation is for this part. Okay. So implies VH equal to 12 by 0.8 15 meters. This is the horizontal component of velocity. Similarly, by substituting 0.8 in the y coordinates, we get the vertical component. So Vv into t minus 5t square equal to 5 minus 5t square. The 5t square part cancels on both sides, and we get V vertical equal to 5 by 0.8, which is 50 by 8, which will be 6.25 meter per second. Now, we got the vertical and horizontal components of the velocity, and thus we finally reach our answer to the question. I'll mark it like this. This is our answer, and if you are asked to calculate velocity, the magnitude of the initial velocity will be root of square of the components, Vh square plus Vt square. You can substitute the values and find the answer. So this is how you solve this question. Bye.